in the form of heat. It could be radiation, microwave, right? It doesn't have to be heat. Molar heat vaporization. 1 mole of liquid to go to gas. You can see that at different temperatures, it's different. As the temperature goes up, you need less energy to make liquid into gas. Why? Because it already has a lot of energy ready to go. So it needs less energy to go from liquid to gas. You understand that, right? Why it goes up, up. As the temperature goes up, this becomes less. Greater energy, temperature, the liquid water, less energy to vaporize. You understand that, right? Okay? And then this is sublimation from solid to gas. Okay, now what the questions are here? Well, the first one is, what is the value of fusion? Delta H fusion. Okay, delta H is actually energy in the form of heat under constant pressure. Okay? So you can take that value and put it there, big deal. Okay? So that delta H fusion is going to be the same number as the problem is giving you. So you can put delta H fusion plus 6.01 kilojoules per mole. Then, the second one is a little bit, it's a good one. It's asking you, is delta H equal to delta U fusion? And explain why or why not. So what do you think? Is for this process of melting, is it delta, we talked about this in the lecture, I know you forgot. Is delta H equal to delta U or not? Huh? Why not? Because it says the volume changes. Remember? And if the volume changes and there is an external pressure in the atmosphere, then work is involved. Plus, minus, depends if it freezes or melts. So because work is involved, you remember delta U is equal to what? Q, which is in this case delta H, plus W. If W was 0, then yes, it would be equal, but W is not 0. When it expands, freezing, or when it contracts, melting, there is work involved. W is different than 0. Therefore, delta H and delta U cannot be equal. Everybody got it? Yes? So that was a good question, right? Now, what about the other one? What's the next one? It says use the appropriate values, two values, from the information given to illustrate the first law of thermodynamics. So, first law of thermodynamics says that energy is conserved, right? So basically what it's telling you is if I can go from here to there, and then I can go from here to there, and I spend so much energy, it will be the same thing if I go from the same point to the same point in one step instead of 2 or 3 or 100 steps. Should be the same energy. As long as the initial step, the initial state of the system and the final state of the system, right? Initial and final states are the same energy-wise, then it doesn't matter what the path is, the energy involved is going to be the same. That's what the first law of thermodynamics really is telling us, right? Conservation of energy. And if you take each step, because you see you have liquid, you can say solid to liquid and liquid to gas, that's 2. Or you can go directly from solid to gas. The sum of the two should be equal to that, from solid to gas. But you have to choose the same temperature, otherwise it's not going to be correct. So if you take 0 degrees Celsius, the same temperature for every process, then that you will see that it works. In other words, Q sublimation, which is really from solid to gas directly, you can go in 2 steps instead directly. You can go from solid to liquid and then liquid to gas, instead directly from solid to gas. So that will be equal to, should be equal to fusion plus vaporization, right? This is solid to gas. This is solid to liquid, and this is liquid to gas. And if you do it at 0 degrees Celsius, you have to be the same temperature, then you find out that plus 50, 0.95 kilojoules is actually equal to plus 6.1 kilojoules plus 44.94 kilojoules. See? You can see that the numbers really do much, don't they? Right? And then it tells us to do an energy level diagram. It's really very similar to the one before, right? You should be able to do it. If you do it correctly, it should look like this. And what the teacher wants you to take away from this hour, 2 hours, it will be more benefit to you to take the lesson of 2 things today than these numbers. These numbers might give you a way to pay the bills. Might. They might not. You might have to choose to do something else, what you plan to do, to be able to survive by paying the bills. So that's not the most important thing. The most important thing to be able to survive, no matter what, if you can find a job based on the things we're learning here today, the 2 hours, is to balance your lives, and these people that play the music demonstrated that, and to have a clear mind, to do self-service like what Stephen did. You're having 2 hours sitting here. He has homework to do too. He is a student just like you are. And he has a lot of things to do. But he chose today to come here and spend 2 hours plus another hour back and forth in bus or whatever he came by bike or food. That's about at least 3 hours he spent to videotape this so some other people will be able to watch it twice or 3 times or people they didn't see it. Selfless service, balance things with music or whatever. That's the most important thing, not the number. Good luck.